Hello everyone and welcome to our channel. We're excited to have you here with us today as we explore the world's largest 16-megawatt offshore wind turbine rolled off the production line, setting a new benchmark in the progress of global offshore wind power equipment in southeast China's Fucheng City. So sit back, relax, and let's get started. GWH252 16-megawatt super large capacity offshore wind turbine. Support structure integrated design significantly optimizes the load of the support structure, reduces structural weight, reduces costs and improves design efficiency. Optimized sea area. Compared with the 8 megawatts unit, the number of holes is reduced by nearly one machine. The sea area is saved by more than 35%. The power generation is increased by more than 6%, and the yield is increased by more than 10%. E-top cabin integrated design. Reduce offshore operation time. One-button startup without debugging. Improve overall machine efficiency. Efficient and reliable transmission system. Guaranteed power conversion to provide excellent power output. Super high power and super large size main bearings that have been in operation in China. Dynamic simulation and strength verification of high-quality electroslag remelted steel ensure high reliability of main bearings. Ultra-long and flexible new blade. Carbon fiber main dying design reduces weight by more than 20%. New independent airfoil design brings high stability and super wind performance. Larger swept area. The diameter of the impeller is 252 meters and the sweeping area is about 50,000 square meters. Smarter wind turbines. Sensing devices all over the body realize early perception, active control, and optimal matching. Smarter wind turbines. Real-time monitoring of meteorological data by lidar, autonomous switching of operating modes, fearless in extreme weather. GWH252 16-megawatt. Refresh the 3 global records of super large unit capacity, super large impeller diameter and the lightest weight per megawatt. GWH252 16 megawatts, ultra-large capacity offshore wind turbine with a unit capacity of 16 megawatts. On November 23, 2022, the GWH252 16 megawatts offshore wind turbine unit, jointly developed by Goldwind Technology and Three Gorges Group and provided by Sichuan Resources with a full set of water cooling system, was successfully launched in Fujian Three Gorges Offshore Wind Power International Industrial Park. This unit has once again set new records for the world's largest single unit capacity, the world's largest impeller diameter, and the lightest weight per megawatt. The GWH252 16 megawatts, ultra-large capacity offshore wind turbine unit, with a unit capacity of 16 megawatts, impeller diameter of 252 meters and impeller sweep area of about 50,000 square meters, is equivalent to the area of 7 standard football fields. Under the full wind speed, 34.2 kilowatt-hours of electricity can be generated per revolution. A single unit can output more than 66 million kilowatt-hours of clean electricity every year, which can meet the normal power consumption of 36,000 households with 3 people in a year. It can reduce the consumption of coal by 22,000 tons and the emission of carbon dioxide by 54,000 tons, with significant energy saving and emission reduction effects. The successful development of GWH252 16 megawatts ultra-large capacity anti-typhoon offshore wind turbine has built a new milestone in the wind turbine equipment manufacturing industry. GWH252 16 megawatts, super capacity typhoon resistant offshore wind turbine has completely independent intellectual property rights, and successfully overcome a series of key technical problems such as super long flexible blades, localization of large main shaft bearings, and miniaturization of super capacity generators. The successful launch of the unit marks a historic leap forward for China's offshore wind power equipment industry, from scratch to existence and from existence to excellence. creating a new benchmark for the development of global offshore wind power equipment, and will help China's offshore wind power industry ride the waves and go steadily to the future. As the core equipment supplier of Goldwind technology, Sichuan Resources has provided a complete set of cooling systems for GWH252-16MW offshore wind turbines, including electric drive water-cooled host, mechanical drive water-cooled host, unit external cooling radiator, high-level water tank, engine room radiator and unit central cooling pipeline. The installation time for the GWH252-16MW offshore turbine can vary depending on the specific circumstances, such as weather conditions and installation methods. Generally, the process of installing an offshore wind turbine involves several stages, including foundation installation, tower installation, nacelle and rotor installation, and commissioning. On average, it can take several days to weeks to complete the installation of an offshore turbine. However, it's important to note that this time frame does not include the time required for site preparation, transportation, and logistics planning, which can add additional weeks or months to the overall process. It is best to consult the manufacturer or contractor responsible for the installation for a more accurate estimation based on the specific project parameters. China has set ambitious goals and formulated comprehensive plans for the future development of offshore wind turbines. The country sees offshore wind energy as a crucial part of its clean energy transition and a significant contributor to its carbon neutrality targets. Here is an overview of China's offshore wind turbine future vision and plan. 1. Targeted capacity. China aims to become a global leader in offshore wind energy. The government has set a target of reaching 10 gigawatts of installed capacity by 2020 and further increasing it to 30 gigawatts by 2030. 2. New offshore wind zones. China plans to develop new offshore wind zones in strategic coastal areas. These zones are designated as optimal areas for offshore wind farm construction due to favorable wind resources, water depths, and other technical considerations. 3. Technological advancements. China is investing in research and development to advance offshore wind turbine technology. This includes developing larger and more efficient wind turbines, enhancing floating wind turbine technology, and improving overall system integration. 4. International collaboration. China actively seeks international collaboration and partnerships in offshore wind energy. The country has established collaborations with international institutions and companies to leverage global expertise and promote knowledge sharing. 5. Policy support. The Chinese government has implemented various policies and financial incentives to promote offshore wind energy development, including feed-in tariffs, subsidies, and tax breaks. These measures aim to accelerate project implementation, attract investment, and create a favorable environment for the industry. 6. Grid integration. China is focusing on improving the integration of offshore wind energy into the existing power grid. This involves constructing and upgrading transmission infrastructure to facilitate the efficient and reliable transmission of offshore wind power to onshore areas. 7. Job creation and economic growth. The offshore wind energy sector is expected to create significant job opportunities and drive economic growth. China aims to develop a robust supply chain, including turbine manufacturing, installation, logistics, and maintenance services, thereby creating a thriving industry. China's offshore wind turbine future vision and plan reflect a strong commitment to renewable energy and combating climate change. The country's focus on technological advancements, policy support, and international cooperation is expected to propel the offshore wind industry and contribute to the global energy transition. There are different types of offshore wind turbine foundations that are used depending on the depth and conditions of the seabed. Here are some common types. 1. Monopile foundation. This is the most common and widely used type of foundation for offshore wind turbines. It consists of a large steel cylinder with a diameter of several meters that is piled into the seabed. The monopile is driven into the ground using a hydraulic hammer or a vibratory driver. It provides stability and support to the turbine structure. 2. Jacket foundation. Jacket foundations are similar to the monopile foundation, but instead of a single large pile, they have multiple steel tubular legs. These legs are interconnected to form a lattice-like structure, resembling a jacket. The legs are secured to the seabed using piles or suction buckets. Jacket foundations are suitable for deeper water depths and locations with soft soil conditions. 3. Gravity base foundation. This type of foundation is a large concrete structure that is ballasted with rocks or other heavy materials. It sits on the seabed and uses its weight to keep the turbine stable. Gravity base foundations are often used in relatively shallow water depths and in areas with strong currents or soft soil conditions. 4. Tripod foundation. A tripod foundation consists of 3 steel tubular legs that are anchored to the seabed. These legs extend above the water surface and support the turbine. Tripod foundations provide stability in a variety of soil conditions and water depths. 5. Floating foundation. Floating wind turbine foundations are used in very deep water depths where fixed bottom foundations are not feasible. These foundations use pontoons or other buoyant structures to keep the turbine afloat. They are anchored to the seabed using mooring lines, which provide stability. Floating foundations allow wind turbines to be deployed in offshore areas that were previously inaccessible for wind energy production. The choice of foundation depends on factors such as water depth, soil conditions, wind conditions, and cost considerations. Each type of foundation has its advantages and disadvantages, and ongoing research and development aim to improve the efficiency and sustainability of offshore wind turbine foundations. An offshore wind turbine operates through a series of steps to convert wind energy into electricity. Here's a breakdown of the process. 1. Wind capture. Offshore wind turbines consist of a tall tower with a rotor at the top. The rotor is equipped with 2 or 3 rotor blades, typically made of fiberglass reinforced epoxy or other lightweight materials. The rotor blades are designed to be aerodynamic and have a curved shape, called an airfoil. As the wind blows, it exerts a force on the rotor blades, causing them to rotate. 2. Energy conversion. The rotation of the rotor blades is connected to a generator located inside the nacelle, which is the housing atop the tower. The generator consists of a large electromagnet surrounded by coils of wire. As the rotor spins, the magnetic field created by the electromagnet induces an electrical current in the surrounding wire coils. 3. Power transmission. The electricity generated by the generator is in the form of alternating current AC. This electrical energy is then converted to higher voltage using power electronics located within the nacelle. The converted high voltage AC power is then transmitted down the tower through cables. 4. Substation connection. At the base of the turbine tower, there is an underwater cable that connects the offshore wind turbine to an offshore substation. The substation collects and combines the electricity from several turbines within the wind farm, and it houses equipment for voltage regulation, metering, and other necessary functions. 5. Grid connection. The electricity from the offshore wind farm is transmitted from the offshore substation via underwater cables to an onshore substation. Here, the voltage is further transformed and adjusted to match the requirements of the power grid. The electricity is then distributed through the grid to consumers. 6. Maintenance and monitoring. Offshore wind turbines require regular monitoring and maintenance. Technicians access the turbines using boats or helicopters and perform inspections, repairs, and general upkeep activities to ensure optimal performance and longevity. By harnessing the power of the wind, offshore wind turbines generate renewable energy, contributing to the reduction of greenhouse gas emissions and the transition towards a cleaner energy future.
Thank you for watching. We appreciate your time and attention. Please subscribe to our channel and don't forget to like, comment and hit the notification bell to stay updated on our latest videos. We look forward to seeing you again soon.